Hello everyone, I'm Maryam and thank you for joining this session. I'm going to present my research paper on an agent-based model for flexible customization in product service system. This research is supported by an Innovate UK funded project. First, let's introduce some of the relevant concepts to this research work. Servitization can be described as the movement of businesses from product-oriented to solution-oriented. Product service systems refer to the business models that provide an integrated delivery of products and services. In this context, flexible customization provides a wide range of product and service options for customers in a PSS contract, so-called PSS customization. However, in the literature, this concept has also been referred to as modularization, like the modular production, and also personalization, like personalized product design. In the context of PSS customization, flexibility can be described as a flexibility in service planning for customized product. Now let's have a bit of research background that leads into the contribution of this paper. In high-value manufacturing industries, flexible customization is more crucial for service contracts profitability. This is because fulfilling the customer's requirement is challenging for such industries. This challenge mainly arises from the health and condition monitoring of high-value assets, which causes inherent complexity for PSS contracts. Also, the high level of uncertainty in maintenance and repair planning activities over a service contract complicates the profitability measures. Now, flexible customization aims to provide an opportunity for both manufacturers and service providers to enhance their competitiveness and to satisfy their diverse customers' demand and enhance the confidence in designing the PSS contracts. Based on the described research background and the literature review on flexible customization and PSS, the research gap is identified, and this research tries to answer the question of how flexible customization can influence the profitability of PSS service contracts. The majority of the studies in the field are qualitative and based on historic customer requirements. This study takes a quantitative approach and tries to answer the research question by developing an agent-based simulation model for the PSS contract decisions to enhance the flexible customization in two types of PSS contracts, the spare parts contracts and availability-based contracts. To fulfill the aim of this research, a cost-benefit analysis simulation model is developed for PSS decisions based on a bottom-up lifecycle costing approach. Sensitivity analysis for service costs, service cycle times and the recurrences are completed. The effect of product remaining life on different service contract decision is analyzed. And the simulation model considered a stochastic uncertainty to study a flexible customization for PSS contracts. I would first start with the cost-benefit analysis model. A number of cost events are contemplated throughout a PSS contract. And also at each cost event, a number of cost drivers are considered, as you can see in the table. I'm not going to go through all the details. The events starts with acquire, the component or the machine, like the product, install, operate, standby, consultation, upgrades, and also different maintenance, such as condition-based maintenance, preventive maintenance for repair, preventive maintenance for replace, base maintenance, disassembly if it is required, and also the corrective maintenance for replace and corrective maintenance for repair, the reject event, and also other cost drivers such as penalty and incentives due to the lack of availability or providing higher availability of the product and higher than the customer requirement. The uninstall event, reassembly, and also finally the end of contract, which you may have a different scenarios at the end. A bottom-up activity-based costing is then formulated to calculate the cost of each event and the total life cycle cost. And the benefits includes the revenue from selling a product and offering a service, and is calculated based on the rate of return for purchases and services. To develop the agent-based model, an Illogic University version has been used. This state chart presents the agent-based model in an Illogic software, and different states are connected to each other using a timeout transition. The state chart starts with acquire and then install. And then it goes to the operate phase, and during the operation phase we have a different events such as standby support, consultations, and upgrades, and also a different type of maintenance and repair. In the case of reject, due to a failure of any of the components or the product itself, it may go to the disassembly if it is required. Then we have the corrective maintenance for replace and repair, and then if we've done a disassembly, we did a reassembly, and then it gets back to the operation phase. At the end of the contract, we have the uninstallation from the customer side, and also we have a different scenarios and different cost benefit drivers at the end of the contract. Flexible customization has been formulated based on the following elements, which are summarized in this table. First, the flexibility in terms of the product buying options introduced with the Boolean variable. This means that whether at the beginning it is an OEM, an existing product, or it's a retrofit product. Different service planning are introduced with a double parameter. The level of required availability for the product is introduced as a percentage parameter and variable. And based on this agreed availability, we may have a different incentives or penalty. The selling options for the service provider and customers are introduced with an integer Boolean parameter, which might be selling a product to the customer or renting it or releasing it. Failure rate based on the remaining useful life of the component is introduced as a double variable based on the product remaining life. And at the end of the contract, there are different options which are introduced as an integer Boolean, which includes the remove of the product, retrofit a product, and resell it to a new customer or existing customer in a scenario that you are going to extend the PSS contract. A case study of a bespoke service provider in the UK is adopted. the service provider offers the tailored services for machine tools. In this study, the servitization of a particular CNC machine is considered. The parameters and variables required to complete the simulation model in logic and also complete the cost-benefit analysis are summarized in this paper, in this table. I'm not going to go through the details, but apart from that, we have a fixed rate of 17% per year for depreciation of the CNC machine. And also a 15-year contract has been considered to do the analysis that you can see in the following slides. Two different scenarios mentioned before are considered: the product-oriented PSS for spare part contracts and also the use-oriented PSS for availability-based. The first set of analysis present the effect of the machine remaining life on a PSS contract. Cost benefits are examined and presented as a best fit trend line curve of the probability distribution for each age category with average R value. And as you can see, the uncertainty in the cost estimates of the PSS contract for new products or the products close to their end of life compared to the cost estimates for middle-aged products is higher. The same analysis has been done for scenario 2, and you can see in overall the uncertainty in the benefit estimates in scenario 2 is higher than in scenario 1. Next, the normalized impact of the remaining life and the profitability of the PSS contract in the form of a radar chart is analyzed and presented. The numbers around the chart represent the age of the product, and the percentages are the average profitability of over the 15-year contract. The results shows that in a 15-year contract, the availability-based contract is more profitable compared to the spare part contract. Finally, the impact of the failure rate and scheduled maintenance on the PSS contract profitability are analyzed for scenario 2. For the scheduled maintenance, the profitability is average among the different baseline maintenance, preventive maintenance, and condition-based maintenance. And for the failure rate, it is average between different age categories. And it can see that based on the specific scenario, the contract won't be profitable any longer after a specific year. Apart from the presented findings, the research concludes that the further work will require and conclude that the impact of product age on profitability in availability-based contract is more significant compared to the spare part contract, and the uncertainty in the cost and benefit estimates for PSS contracts for middle-aged products are relatively low, and also the PSS contract profitability is highly sensitive to the product failure rate. And now what next? So to improve the adaptability in service contract against the market demand and implementing the Industry 4.0 would improve the flexibility of the PSS customization in the presented approach. Thank you, and please ask your questions.